Hello viewers, in today's video we are going to talk about buffers. So we all know that buffers are solutions of strong acid, weak base, okay, strong base, weak acid, vice versa. Okay, so these are the solutions which basically resist the change in pH, and they are used for calibrating our pH meters. Okay, and buffers have various other uses also in water treat, in wet chemistry, or you can say water treatment. So the concept of buffers are basically used widely in water chemistry, or you can say wet labs. Okay, so these I told you earlier, that's solution of weak acid, strong base, or you can say conjugate acid and base. Okay, so buffers are prepared widely in the laboratory. You can also buy from the companies that provide buffer solutions for calibrating a pH meter. So you can see this is our buffers. Okay, now buffer solutions can be prepared in the laboratory. So for preparing pH 4 buffers, now for preparing pH 4 or pH 7, pH 10, for usually for pH 4, so this is from the EPHA standard methods. Okay, so usually for preparing pH 4 buffers we have to weigh around 10.2 gram of potassium hydrogen thiolate and dissolve in around 1 liter of the deionized water. Okay, so this will be pH 4, and for making pH 7 buffers we have to dissolve around 3.4 grams of potassium hydrogen thiolate. Okay, because you can see the molecular weight is around 136.9. okay, 09, and then 3.55 gram of sodium hydrogen phosphate, disodium phosphate, and then this is the calculation for 1 liter of the water. So we will do the same thing in around 100 ml of the water. So the weight will be divided by 10. So for example, for pH 4 the weights will be 10.21 gram divided by 10, so it will be around, okay, we will calculate it and then weight. So 10.21 by 10. So from the calculation this is around 1.10. okay, for the pH 4 buffer, and this molarity is around 0.05 molar. Okay, now we will add around 100 ml of the deionized water. Now we will shake this for a while till it homogenizes and mixes very well, and then we will do the separate similar kind of calculations for the pH 7 buffer. So here we need 0.34 grams and 0.35 gram of phthalate and phosphate salts, and I'm doing this for 100 gram. Similarly you can do this for 1 liter or 2 liters or 5 liters. So here the shelf life is around is for 3 months. You can use it for 3 months and then discard it. Okay, now we have already prepared the pH 4 buffer, which is here already dissolved, and for pH 7 I have transferred the salts. I have skipped this step. I've already told you the calculations, what calculations we will be using for preparation of pH 7 buffer. Okay, now we will try to measure the pH of this prepared buffer. So you can see here that the pH of the prepared buffer solution with the addition of around 1.02 1 gram or 10 gram in 1 liter of the, so 1.02 gram in 100 ml of the deionized water, which molarity is 0.05. so this pH is around 4. So this is successfully you can say validated. So in this way you see that this way we spend too much money on buying, so we can, if we have the salts in our laboratory, so we can prepare the buffer, and that could be fresh. Okay, and that also the shelf life is around 3 months. Now, and this is this pH is at 20 degrees C, and we know that temperature has a profound effect on the pH of the water. So here if the temperature is 25, so it should read 4.01. Okay, now let us check the other buffer solution which we are preparing. Okay, and also for the pH 8 we can use potassium hydrogen thalate, okay, and sodium disodium hydrogen phosphate, and that also we can, I mean, there are certain calculations for pH 8 and pH 10, okay, and for pH 10 we have to use sodium tetraborate, okay. Simultaneously in our next video we will be talking about the electrolyte solutions that we use for storing the our pH probes. We can use pH 4 pH 7 buffers also, and also we can use 3 molar of KCl filling solutions, okay, in case we don't have any AgCl electrode. Okay, now let us check the other prepared buffer. Now this is the pH of the finally freshly prepared buffer solution using sodium dihydrogen phosphate and potassium hydrogen thalate. Okay, you already saw what amount I have added in 100 ml of the water. So this is all about the preparation of buffer in the laboratory. Okay, if you don't have the buffer solution provided by the manufacturer, you can prepare your own and save lots of money, okay, and save a lot of any, you can say, expenditure or a cost, okay, that would incur in buying these standards from the manufacturer. They also have a shelf life, and this also have a shelf life.